Hello everyone, welcome to the video. This is not going to be another typical solution video where I'll go through the questions and solve it step by step. I feel there is almost no use of watching such a video. What I'm going to do is I'll give you some hints, I'll tell you about the topic, the toughness level of the questions. The solutions are written. Whenever I scroll down the questions, you will see the solutions are written, but you can choose to ignore them, and just with the hints that I give you can try to solve the question. Okay, so that if you interact with the video, like you stop it and then you try to solve it in between, you can derive the maximum benefit from it. Okay, so I know some of you might be in 11th, some of you might be in 12th, depending on your present level of knowledge. I wouldn't say 11th class students will derive much use by seeing this video. Maybe they will just get an idea of what chapters, what difficulty level the questions come from. But other than that, they will not be able to fulfill the purpose for which the video is made. That is to slightly push you in the direction of the solution. Okay, so let's begin. So first question, we have a disc over here which is attached to the spring, and this is inside a ring. Okay, so the spring goes over the ring like this. Now the disc can roll on the inside of the ring. So there are two things here, there is gravity as well as there is spring force. Okay, so this is a question of SHM. So our job is to displace it a little bit and then write the uh, torque on it. Okay, or you can try to write force also. I have done it by torque. You write the torque on it with respect to some inertial axis. Okay, so I have chosen the ICR as the axis, and then I have written these equations and we get the answer. So you can choose to see the solution, or you can stop the video and you can try it on your own. I'm not going to explain the solution. So moving on to the next question. Now this question, if you don't know this particular way of solving the question, it's going to be a little lengthy. But with this way, the vector diagram way, it can be solved very quickly. So the concept behind this question is that when you are having a particle which is going to hit another stationary particle, then the total momentum of the system is what? m1 plus m2 into vc. So you can divide it using section formula in the ratio m1 is to m2. Now what happens is that upon collision it might go along some other path, but with respect to the center of mass, the linear momentum magnitude remains constant, and that magnitude is mu into v relative. So when we are drawing the vector diagram in the frame of center of mass, we would get two vectors, one for first particle, the other one for the second particle, and both the vectors will be of equal magnitude. So this is the momentum in the frame of center of mass after collision for the two particles, and hence the final momenta for the first one will be along this, and for the second one will be along this. So here we have been told that this angle, we have to find the maximum angular deviation. So by this idea, what we can say is that you can take this point as the center and you can draw a circle. You can draw a circle of radius mu into v relative. Now when you draw this circle, so when will you get the maximum deviation? When you are having the tangent, isn't it? When the final momentum of the first particle is along the tangent. So that is the idea I have used to solve this question. Okay, so it is an idea which is given in Irodov, the theory book of Irodov, mechanics book. Okay, not the problem book. Moving on to the next question. Again, now this question should be done using the options which is given. Okay, so the magnetic field in this case is present only in this region. Okay, so magnetic field is only in this region, and hence when it goes to the other side there will be no EMF. So first of all, you should just look for the graphs which are having breaks in between, which is only option A and D. And then upon that, further to solve the question, you need to write the expression of the EMF, and then you need to see at t equal to 0 what is the situation, because these two options differ in their t equal to 0 situation, using which we can solve the question most efficiently. It will take a little bit time, but still you'll get it maybe within 3 minutes. Okay. Next question is Vernier scale, but here Vernier scale is with a twist. So if you count the number of main scale divisions, it is 1, 2, 3, 4, 5, 6, 7, and the number of Vernier scale divisions is 10. So each Vernier scale division is equal to zero point 0.7 times the main scale division. Okay. So now when this is the reading, so what is happening is that you can see these two lines are coinciding. So the length of the object is from here to here, and we know that this length is how much? This length is 0.7. So you should be able to get the answer. Next, question 5. This loop is going inside the region of magnetic field. So you can write the expression for current, using which we can write the force, and then from there you can get the equation of motion. So you can find x in terms of velocity and initial velocity, and similarly you can find the time as well. Okay, similarly you can find the time. So everything starts from this equation. Once you get the expressions, you can substitute the values which are given, like this one, these all values you can substitute and check that which one is correct. Okay. And for option B, you don't need to do any calculation. Okay, so at least if you had lack of time, then you could have at least chosen option B, because there is some part marking for that. Then next, this is just you should know significant figures, that these terms, if you are able to analyze what is the significant figures here, you'll get the answer. So the least number of significant figure is over here, so accordingly you should get the answer. Next question. The wave is given. We know when it reflects while going from a rarer media towards a denser media, then the reflected wave undergoes phase change of pi, which we say for sinusoidal waves, but in reality it is like this, that if you are having some function f of x, and if you want to reflect it, okay, if you want to reflect it, then what should happen? If it is a fixed end, the reflected function has to be both going towards the left. This was going towards right. Reflected function has to go towards the left, as well as it should be inverted. Okay, so the initial wave which was coming over here, if it was f of x minus vt, then the reflected wave that we get should be minus f minus x minus vt. Minus x gets replaced instead of x because you are reflecting about y-axis, and minus outside because it has to be inverted, so it has to be reflected about x-axis as well. Okay, so using this idea, we get options A and D, but there is a bit of confusion here, which is that x equal to 0, if you assume as this point, then you don't get these answers. Then there will be some constant term added, and we don't know what is the length of the wires. So these are not like perfectly correct answers, because if the reflection happens not at x equal to 0, if you are reflecting some function, let's say I'll take an example of a function f of x. If you are reflecting it about some line, let's say x equal to a, then this will be the reflected function, whose equation will be f of 2a minus x. Now you think about that, why it should be f of 2a minus x. But due to this fact only, these two answers are like tentative. It is like every time we are taking the point in consideration as x equal to 0, then we would get these equations. But if we don't consider that, then I don't think we would be getting any answer here. So that's why tentatively answers are A and D. Next, question number 8. So the platform is oscillating up and down. So they have asked the maximum variation of object's weight. So maximum variation will be what? If the platform, like from the mean position, when it is maximum down, it has a max acceleration a upward, and when it is up, then it has a max acceleration a down. Then maximum variation in weight would be what? Like maximum weight would be m into g plus a, and minimum weight would be m into g minus a, and hence 2ma should be the maximum variation, right? Then next question. Cube has these many photons having this much frequency. So we are required to find the amplitude of magnetic field uh, if the electromagnetic waves are inside this cube. Okay, so that means the total energy due to the electromagnetic waves and total energy of photons, that should be equal. So you can multiply the number of photons with the energy of a single photon and equate it to energy density. Now this, if you remember, is the total energy density. It is not just in magnetic field. Just in magnetic field will be b square by 4 mu naught. This is the total energy density into the volume of the cube, which gives you the value of b. Okay, value of b comes out to be near about this. Then next question, we are having these two plates. Now this is a standard question which you might have done. This is there in many materials. There is some heat transfer from here to here, then we place two plates in between. Now they are asking what will be the net heat current. Okay, so initially you are having these two temperatures, and when you apply Stephen Boltzmann law, so you will get this kind of expression. But when you are applying for this case, now there are two intermediate plates, T1 and T2. So you have to write for these two, then these two, then these two. It is given that the heat transfer takes place only between adjacent plates. Okay, so in 3 steps you will write. Let's suppose Ws is given. So Ws will be sigma A Tp to the power 4 minus T1 to the power 4, and so on for the next plate and then the next plate. Please try on your own. Next question, I would say, is a little difficult one because it will take time to think all of this and solve this. It starts from here. It's given that it is the light is getting completely polarized, which means that it is hitting here at Brewster's angle, and from there then you go backwards. You imagine that if it is hitting at Brewster's angle here, then at what angle would it be incident, and then draw the ray back to the original point, and then you'll have to use some maybe Lami's theorem or geometry, and then you'll get the answer. Okay, so try it on your own. Next question, error analysis. So it's given that b value is this much. Now delta b by b is what we have to calculate, and then finally get the value of delta b. So we know this error analysis formula. Using that, we'll substitute all the values, and we get the answer. Next question, electron is given in n equal to 3, and neutron having thermal energy this much has same wavelength. So our solution starts from here, that this energy is equal to p square by 2m, and then for any electron we have Bohr's quantization rule. So using that, you can write the expression for lambda, and then you can make sure that the condition in the question is satisfied. So the temperature, it is given by this formula. You can try to write temperature in terms of this. Okay, so try on your own. Once again, your solution starts from here, that you equate p square by 2m to this thing, and then from expression for Bohr's quantization rule, you get the idea about lambda and use it in the expression for temperature. Next question is quite straightforward. So dipoles are given in various orientations. You just need to know two things for solving this. One is that due to a dipole in the end-on position, how much is the field? It is 2 kp by r cube. And in the broadside on position, how much is the field? It is in opposite direction, and it is kp by r cube. And if you know these two facts, then you will be able to get the answer very quickly. Okay. not much calculation involved. Next question, we are having this element of some impedance, and there is this input voltage, and we are required to match it with the given graph. Okay, so in this situation you can just check, like if there is just pure resistance given, then what will happen, the voltage will match exactly with the current diagram. I mean, exactly as in the amplitudes might be changed, but other than that, it will match with the diagram. And it can also match if the circuit is in resonance, and that is somewhere happening over here. So, in general, what will happen if inductor or capacitor is there, then you will have to calculate the equivalent Z, and using that, you can calculate whether it is leading or lagging. The maximum value of current you can calculate by using V naught by Z. So just with this idea, you can solve the question. You might not have to solve it exactly, okay? So, but you will need to calculate how much is XC, XL, Z, all those things. And then just use the graphs to match, like in which case current leads, okay? Like you should know that in capacitor circuit, purely capacitive circuit, or the case where capacitor dominates, XC is greater than XL, there what happens when XL is greater than XC, there what leads. So if you are able to, if you know these things, you will be able to solve this question. Now this one is interesting because once earlier also, if I'm not wrong, JEE had asked a question where it was about the electrostatic part of nuclear binding energy, and there they had derived this relation. And you can think about it why it is this way, because if you take a particular proton and consider the potential due to all the other protons combined over here, then you should get an expression like this. So think about it, why it should be that way. So here what I have done, I have solved this. Other things are quite straightforward, like they come directly from your theory knowledge, like X-rays, okay, or hydrogen atom. Those things come directly from your theoretical knowledge. This one, once JEE had asked, they have used in a way that idea only, but this also can be derived. But for S, that is E is practically independent of Z, I have given both 3 and 4, because for continuous X-rays also, it does not depend on uh, the value of Z, the atomic number, right? It depends on what is the accelerating potential, but there is no option with S3, okay? So there is only option with S4, and that's why that would be the correct answer. So that was the physics paper 1. Uh, the solutions are given. I'll attach the PDF with this video. So if you want, you can go through that, but please just try it on your own. Otherwise, just seeing the solution videos are not going to help you in any way. Okay.